Okay.
So polar coordinate system coordinates basically are defined by r theta, and in case of Cartesian coordinate system, coordinates are considered as xy. Okay. Now, in case of conversion from polar to Cartesian, if we consider two-dimensional coordinate system like that, xy, okay, then this is a vector which is considered r vector, and we consider the angle is theta. So we always consider the angle produced with positive x-axis and anti-clockwise. Okay, so we consider positive x-axis as a reference line, then from that line anti-clockwise to this vector r considered as a theta angle theta. Okay, now r theta, this r theta represent the polar coordinate. Now if we try to find out the Cartesian coordinate xy, we have to apply trigonometric formula, because we know that if we produce a right angle triangle like that, so in that case this part is considered the x component of this vector, which is x, or we can consider rx, and this part is considered y or ry. Okay, so this part is also ry or y. Okay, or y. Then we know that according to the cosine formula, we know that cos theta is equal to base divided by hypotenuse. Okay, so base is x and hypotenuse is r, the magnitude of the vector r. Then we can say x equal to r cos theta. Okay, x equal to r cos theta. Then this is the basically conversion from polar to Cartesian. This is the x component. Now in case of y, you can say y is equal to similar way r sin theta. Okay, r sin theta. So this is the conversion from polar to Cartesian. If say the magnitude of a vector is given 10 and angle is given like say 30 degree. Okay, 30 degree. From this is given in polar form. You can easily convert this polar form into Cartesian form. Okay, which is x equal to r cos theta and y equal to r sin theta. Then x will be 10 cos 30 degree and r will be 10 sin 30 degree. Okay, so this is the procedure to convert polar to Cartesian. Okay, now the thing is that if we consider the vector is in say third quadrant or fourth quadrant, just like that. So this is a vector, given vector is say a vector. Okay, a vector, and this angle is given like 60 degree. Okay, 60 degree. So in this case the angle produce this vector with negative y-axis. Okay, so in this case you can follow two way. So first is conventional method, just we consider this positive x-axis as a reference line, then go to anti-clockwise. Okay, so this is the angle produced this vector a with positive x-axis. So this angle will be 70 degree minus 60 degree. Okay, so the angle produced this vector with positive x-axis is 270 degree minus 60 degree, which is basically 210 degree. Okay, so this is the angle produced this vector with x-axis, and the magnitude maybe magnitude say consider the magnitude of this vector is 5. Okay, then you can easily just find out the vector, or you can convert this Cartesian polar form to Cartesian form like that. Say a vector, in case of a vector, x component is say 5 cos 210 degree I plus 5 sin 210 degree j. Okay, so this is the procedure to convert polar to Cartesian. Another way is here, we know that in third quadrant, this is the third quadrant. In third quadrant x is negative and y is also negative. Okay, so x negative, y negative. Okay, and here vector A produce 60-degree angle with negative y-axis. So that's why you can say x component of this vector x is equal to ax is equal to a sine 60-degree and ay is equal to a cos 60 degrees. So according to the trigonometric formula, because the angle produced here vector A with negative y-axis, so that's why we have to consider cos theta for y-axis and sin theta for x-axis. Now we have to add the sine also, because x component is negative, so that's negative, and y component is negative. So this is the conversion from polar to Cartesian. So this result and this result will be same. You can follow any way. Okay, so either this or this. Okay, so this is the procedure to convert a vector, mainly polar to Cartesian conversion. Okay. So do you have any question regarding this conversion?
No, sir.
Okay. Okay, so this is the procedure to convert a one vector from another. Procedure to Cartesian to polar to Cartesian conversion. Now say the vector is given like that. So this is vector A, and another is vector. So say this angle is 30 degree. Another vector is given like that. So this is vector B, and say this angle is 20 degree. Okay. Now what will be the angle for vector B? How can we say magnitude of the vector B is given 5, and the angle produced with a vector is 20 degrees. So in this case, how can we find out the vector B?
So it's going to be 180 minus 20 degree.
180 minus 20 degree.
Yes.
Now the procedure is basically you have to shift the coordinate, or you have to shift the vector, so that the tail of the vector remain in the origin of the coordinate. Okay, so if we draw the axis like that, xy, then the angle produced B vector with positive x-axis will be 30 plus 20, it will be 50 degree. Clear? Is it clear?
Sir, can you repeat this part again?
Say a vector is given like that. In this case, you cannot draw the coordinate like that, xy, or the vector is given like that. You cannot draw the coordinate just like that, xy. Okay, so there is a procedure. You have to keep the tail of a vector at the origin of the coordinate. So if the vector is given like that, then in this case you have to draw the coordinate just axis like that, xy. Okay, so here the tail of the vector remain in origin. Okay, so in this case the angle produces, say, this is the theta. Okay, so here the angle produced vector B with vector A is 20 degree, but vector A produced 30 degree with x-axis. Now if we shift the coordinate or axis, so in this case uh, just vector was given like that. So this is vector B vector produced 20 degree angle with a vector. Then if we draw the coordinate just like that, so this is the origin and xy, then the angle produced this vector B with positive x-axis will be like that. So already 20 degrees given with a vector, and a vector produce 30 degree angle with x-axis. So the angle will be 30 plus 50, 20, it is 50 degree. Clear?
Yes, sir.
Okay, so this is the procedure. How can we just find out the vector in unit vector notation from polar to Cartesian? Okay, polar to Cartesian conversion. Now x is equal to r cos theta and y is equal to r sin theta. Okay, so it's not the exact formula, because x can be r sine theta and y can be r cos theta, because say the angle is given this angle. So in this case you can say the vector is r vector. In this case you can say x equal to r cos theta, y equal to r sine theta. But if the angle is given like that, the angle produced this vector with positive y-axis is theta, then in this case x will be r sine theta and y will be r cos theta. Okay, so this is not the exact formula, but if the angle is given with positive x-axis and vector is in first quadrant, then you can say x equal to r cos theta, x equal to y equal to r sine theta. Okay, okay. Now in the now the conversion from Cartesian to polar. So if we apply the Pythagoras formula, we know that this part is x, this part is y. Okay, according to the Pythagoras formula, we can say r square is equal to x square plus y square. Okay, then we say r is equal to the magnitude of this vector will be x square plus y square. So this is for two-dimensional case. If we consider three-dimensional case, r equal to root over x square plus y square plus z square. So this is the procedure to find out the magnitude of a vector and also conversion from Cartesian to polar. Now in case of theta, how can we find out the theta? If we divide this equation, equation 2 with equation number 1, we can say y by x is equal to r just same, so just cancel out, then you can say sine theta by cos theta will be tan theta. Okay, tan theta, and finally you can say theta is equal to tan inverse y by x. So here y represent the y component of the vector and x represent the x component of the vector. So this is the procedure to convert Cartesian to polar, and this is the procedure to convert polar to Cartesian. Okay, so this is the main procedure. Now let's solve a problem related to these topics. Say in two-dimensional case, xy case, vector A, and this angle is theta 1, vector B, and this angle is given theta 2, and another vector like that. Say this is vector C. Okay, vector C. Say this angle is theta 3. Okay, is given. So here the question is find out the resultant vector, magnitude and direction of the resultant vector. Sorry, resultant vector. Okay. So magnitude and direction of the resultant vector. So resultant vector means the addition of these three vectors. So you can say r is the resultant vector, which is equal to a plus b plus c. So this is the way to first find out the resultant vector. Then r is the magnitude of this vector is r, and theta will be the angle produced this resultant vector with positive x-axis. Okay, so first we have to find out the a vector, b vector, and c vector. And in case of a vector, we have to calculate a cos theta 1i plus a sin theta 1j. Okay, so a is given, magnitude of this vector is given say 3, and theta 1 is given 60 degrees. Okay, now if we put the values 3 and 6, we can easily find out the vector in unit vector notation. Say result, let us consider the result is like that. Say 3i, not 3y, say 2.3i plus 1.3j. Okay, so just this is not the exact result, just we consider this is a vector. Okay, so you have to calculate this. Okay, you have to calculate this. Then in case of b vector, similar procedure. In case of b vector, okay, in case of b vector, magnitude b, say b vector is equal to 5, b vector is equal to 5, okay, and theta 2 is given 30 degree, okay, theta 2 is given 30 degree. So in this case you can follow two ways. First is in fourth quadrant, x positive, y negative, then you can say b sine theta 2 minus b cos theta 2, okay. So this is the x and y component. But another way is just to calculate the total angle produced from positive x-axis 20 clockwise of this vector. It is 270 degree plus theta 2. Then you can say b cos 270 degree plus theta 2 is given 30 degree. So 30 degree I plus b sine 270 degree plus 30 degree j. So this is vector b, and in case of c, magnitude says c equal to 7, and angle, in this case angle will be theta 1 plus theta 3, which is 60. Say theta 3 is given 40 degree, okay, theta 3 is given 40 degree, so 60 plus 40, it will be 100 degree. Then you can say c equal to c cos 100 degree I plus c sine 100 degree j, okay. Now these three vectors are in pole Cartesian form basically, so basically I in xy form, okay. Then if we put the value of these three vectors here, okay, just add the x, add the y, and add the z, and there will be answer like that. Particular value I plus particular value j plus particular value k. Now from this you can easily find out the magnitude, root over x square plus y square plus z square. And in case of angle, so there is no k value here, sorry, there is no k value, just I and j. So in this case theta will be tan inverse y divided by x. So this is the procedure to calculate the vectors in polar form and Cartesian form. So do you have any question regarding this problem?
No, sir.
Okay, so I think there is a tutorial video like that type of question. You can, if you solve that, and you can easily just find out the uh, basic thing here, okay. Okay, so next topic is vector and scalar product, okay. So dot product, okay, dot product, dot and cross product, basically dot product and cross product. So in case of dot product, you can say a vector dot b vector is equal to just ab, magnitude of this vector is a, magnitude of vector b cos theta. So this is the formula for dot product, and for cross product a cross b is equal to ab sin theta. Another thing is that here the cross product of two vector is a vector quantity, okay. So that's why you have to write down a unit vector n cap, okay. But the dot product of two vector gives result which is scalar quantity, okay. So this is the formula for dot product and cross product, okay. Okay, so here the thing is that in case of unit vector notation, if we consider I, J, K form, I Along the x-axis is I, along the z-axis, sorry, y-axis is j, along the z-axis is k. Okay. Then in three-dimensional unit vector notation, if we try to find out the dot product, say I dot I, I dot I. If we follow this formula, so magnitude of I equal to what? What is the magnitude of a unit vector I?
So 1.
It's 1. So 1, and for I is 1, and cos, the angle produced similar vector is 0 degree angle. Okay, so we can say angle is 0 degree, so it's 1. So we can say here for similar unit vector I dot I, j dot j, and k dot k, k dot k, result is 1. Okay, result is 1. Now in case of different unit vector, say I dot j, I dot j, so in this case magnitude 1, but cos, so you know that x, y, z all are perpendicular each other, so I and j produce 90 degree angle each other. Okay, so cos 90 degree is 0. So in case of different unit vector, the result is 0. So I dot j, I dot k, or j dot k, if the result is 0. Okay, now let's go to for cross product. In case of cross product, I cross I cross I is 1 sine 0 degree. So sine 0 is 0, sine 0 is 0. So that's why for cross product, for similar unit vector, I cross I equal to 0, j cross j equal to 0, j cross j equal to 0, and also k cross k equal to 0. Okay, k cross k equal to 0. Okay, so this is the result for dot product and cross product of unit vectors. Now if we consider different unit vector in case of cross product, say I cross j, so here 1 and sine 90 degree. Okay, sine 90 degree, but there is a unit vector because the cross product of two vector is a vector quantity, so that's why there is a unit vector which is basically the remaining vector, which is k. And in case of sine, you have to follow the right hand rule. Okay, so right hand rule, if you move to 8 I to j, then thumb represent the remaining vector. So say if we move I to j like that, I to j, okay, I to j, so in this case the vector is k, but if you move j to I, j cross I, okay, so in this case 1 sine 90 degree, but the vector will be minus k, because if we move to just j to I, it will be downward, j to I, it will be downward, so that's why the result is minus k. So the procedure to memorize this, you can say I, j, and k, then I. If you follow the same circle, I, j, k, I, j, k, I, then the result will be remaining vector I cross j equal to k, j cross k equal to I, k cross I equal to j. But if you move opposite direction, say I cross k, it will be minus j, k cross j equal to minus I, and j cross I is equal to minus k. Okay, so this is the procedure for unit vector notation. Okay, now say there is a equation like that, I cross j dot k. So what is the result here? I cross j dot k equal to what?
0.
0. I
Yes,
cross
sir.
j equal to k.
No, sir,
Then
1.
yeah, k cross k equal to 1. Okay.
So by cross,
And if
isn't it
yeah for
supposed to be 0?
I cross j equal to k, then k dot k equal to 1.
Oh, right. Okay.
Yeah, okay. So this is a particularly a conceptual question, like say a question is given like that, I cross j dot k equal to what, or j cross I dot k equal to what. Okay. So then next, let's find out the component of a vector along the direction of another vector. So before going to this part, let's see the angle between two vectors. So if we consider two vectors is A and B, so this theta is the angle between vector A and B, not the angle described in previous case, which was tan inverse y by x. Okay, so this theta and this theta are not same. Okay, so this theta is the basically the angle produce a single vector with positive x-axis, and this theta is basically the angle between two vectors. So in this case there is no relation between the coordinate system, there is no coordinate involved here, but here basically this theta is the angle produced with a single vector, so produce a single vector with positive x-axis. Okay, so this theta and this theta are not same. Okay, so this is the basically the difference between the angle between two vector and angle produce a single vector with positive x-axis. Okay, now if the question is given like that, just find out the angle between two vectors, then you have to just use the formula a b cos theta. Okay, say vector A is given like that, vector A is equal to 3i minus 2j. Okay, 3i minus 2j, and then vector B equal to 2i plus 5j. Okay, so this is two dimensional. Okay, three dimensional is also possible. Okay, so just this is two dimensional case, ij only. So in this case, say first question is given, find out the theta angle, or the angle produce vector A with positive x-axis, and also angle produce vector B with positive x-axis. Then in this case just theta will be just like that, theta is equal to tan inverse minus 2 by 3 for vector A, and for vector B theta will be tan inverse 5 by 2. So this is the procedure to find out the angle produce a single vector with positive x-axis. So this is the angle produce vector A with positive x-axis, and this is the angle produce a vector B with positive x-axis. Now say the question B is given, find out the angle between vector A and B. Find out the angle between vector A and B. So in this case there is no coordinate is involved. You have to just find out the angle using this formula, A dot B dot product of these two vector equal to AB cos theta. Okay, AB cos theta. Then finally you can say theta equal to cos inverse A dot B A dot B divided by AB. Okay, So here A is the magnitude of vector A and B is the magnitude of vector B, and A dot B, in case of A dot B, just you have to follow that formula, A dot B, A dot B. So since the dot product of different unit vector is 0, so don't need to find out the dot product of these two and these two. Okay, just I dot I and j dot j. So I dot I is 1, so 3 into 2 is 6. There is a minus sign, so minus plus is minus, so 2 into 5 is 10. Okay, not try to find out the 3 into 5 is 15 I dot j, because I dot j is 0. Okay, so this part 0 and this part is 0. Just find out the similar dot product for similar unit vectors. So this, that's a dot b will be minus 4. Okay, so this is the procedure to find out the a dot b. And in case of magnitude of a, this is equal to root over 3 square plus minus 2 square minus 2 square. Okay, and for b root over 2 square plus 5 square. Okay, now if we put the value of a dot b, a and b here, you can easily find out the angle between a and b. So I think I think it's clear to you how what is the difference between the angle produced a single vector with x-axis and angle between two vectors. Okay.
Yes, sir.
Okay. So this is the procedure, and next there is a question like that. Component of a vector. The two vector is given. So component of vector A along the direction of vector B, or you can say also the projection of vector A along the direction of vector B. So if we draw the vector, so like that, say this is vector A, and here is vector B, okay, and the angle between these two vectors is theta. Now if we draw a perpendicular line from A vector to vector B, then you can say this part will be A cos theta. A cos theta. This A cos theta is called the component of vector A along the direction of vector B, or you can say the projection of vector A along the direction of vector B. Okay, and also parallel component, perpendicular component of vector A along the direction of vector B. So if we apply the dot product formula, you can say a dot b equal to ab cos theta, then you can say a cos theta is equal to a dot b divided by b. So if the question is given like that, just find out two vector is given, a equal to 3i plus 2j plus 5k and b equal to 2i minus 3j plus 2k. So in this case, just find out the projection of vector A along the direction of vector B, or say the component of vector A along the direction of vector B. Then in this case, if you find out the a cos theta, if theta is given, or if we apply this formula, a dot b divided by b, then the answer will be same, remain same, because this answer and this answer is same. So just a cos theta or a dot b divided b represent the component of vector A along the direction of vector B. Then what will be the component of vector B along the direction of vector A? So in this case, if we draw a perpendicular line from vector B to vector A, then this will be b cos theta. So b cos theta represent the component of vector B along the direction of vector A. So b cos theta or a dot b divided by A is called the component of vector B along the direction of vector A. In Bengali, it's called lombo বিক্ষেপ যেটা বলে আর কি. Okay. Okay. So this is the component of vector A along the direction of vector B or perpendicular component. So if the question is given the parallel component, the question is given the parallel component. So in case of parallel component, just the formula will be like that: A sine theta. Okay? A sine theta. A sine theta gives the parallel component of vector A along the direction of vector B, which is basically, if we draw a parallel line to vector B, then this part will be A sine theta. So that's why this is called parallel component. Okay, I think this part is clear to you. Any question regarding this component of any vector to another vector?
Sir, can you explain the parallel component again?
Yes, of course. Say the vector is given A, this is vector A, okay, and this is vector B, okay. This angle is given theta. So if we draw a perpendicular line to vector B, that's why this is called perpendicular component or component of vector A along the direction of vector B or projection of vector A along the direction of B. But if there is a coordinate like that, this coordinate given. So if we draw a perpendicular line, parallel to vector B, a parallel line to vector B from the top of the vector A, then this is called A sine theta. A sine theta. So due to this case, if the question is given like that, find out the parallel component of vector A along the direction of vector B, then you have to find out just A sine theta. Clear? Okay. So these are the component of vector. All are related to the dot product of two vectors. Now, before going to the cross product, just I want to share a question pattern. Basically, it's a question set like that. Say vector A is given here. Okay, so A vector is equal to like that 3i plus 2j minus 3k. Okay. Another B vector is given like that, B equal to minus I plus 2j plus 4k, and C vector is given like that, C equal to plus 2i minus 3j plus 1 just k. Okay, now first question is find out the fourth vector D such that D minus C minus B plus A equal to 0. So you have to find out the fourth vector D. I think it's very easy to you. Just first calculate this. D equal to, here D equal to D will be here A plus B, A plus B plus C. Okay, now if you put the values of A, B, C, or if you add the values, because the relation is basically A plus B plus C, so 3 minus 1 plus 2 gives the X component, 2 plus 2 minus 3 J, and minus 3 plus 4 plus 1 J. Okay, so this is question number A. Now question number B, find out the angle between A and B. Okay, the angle between A and B, or the angle between A and D vector. A and D vector. So in this case, you have to apply the dot product formula. Okay. And question number C, like that, component of vector A along the direction of vector B. Okay, so this is a one set question. First one is just you have to find out the particular relationship between vectors. Okay, just vector addition, subtraction, or particular relationship in component form. Then second one, just you have to apply the dot product, okay, to find out the angle between two vectors. And last one, just component of vector A along the direction of another vector. Okay, So this is one set question. Say 3, 4, 3. So this is 10 marks. Okay, I think you can solve this problem. Okay.
স্যার লাস্ট কোশ্চেনটা যদি আমরা প্যারালাল কম্পোনেন্ট বা পারপেন্ডিকুলার কম্পোনেন্ট যে কোনো একটা বের করি আনসার কি সেমই আসবে?
No. Parallel component is basically a sin theta, and perpendicular component is a cos theta.
স্যার এখানে তো বলছে শুধু কম্পোনেন্ট, তাহলে কোনটা বের করব?
না, component of vector A along the direction of vector B বলতে যেটা বোঝাচ্ছে সেটা আসলে ওই perpendicular component basically a cos theta. Parallel এর জন্য exactly parallelly বলা থাকবে. Okay, so this is the procedure to solve a one set problem. Next, for cross product, basically A cross B, for cross product A cross B is equal to AB sin theta, and there is a indicator here. Now, in case of calculating of A cross B, you have to follow a particular matrix A cross B. In this case, just I, J, K, okay, and here is AX, AY, AZ, okay, and BX, BY, and BZ. So if the vector is given two dimensional, you have to write down K00 here, okay, clear? If you put the value IJ then multiply that it's not right answer, okay. So in case of two dimensional case, you have to also write down the K00, okay. So then I, in case of I, if we consider I, okay, so if we just this AY BZ, there is a minus sign, then multiplication of these two AZ BY, okay. Now in case of J, you have to write down minus sign first for J minus sign, and AX BZ minus AZ BX, okay. And in case of K, this part, so AX BY minus AY BX, okay. So this is the procedure to calculate the cross product of two vector A cross B, okay. And this is a vector also, this result is a vector, okay. So this is the procedure to find out the cross product, okay. And from this, the basically parallel component idea comes from this part, basically from cross product A sin theta will be A cross B divided by B, or A sin theta, okay. So this is the procedure to calculate the cross product. And if the question is given like that, three vector is given A dot B cross C, then for that type of question, you have to first find out the cross product of these two, because cross product of two vector will be a vector product, a vector quantity. Then A dot B will be a scalar quantity, okay. Okay, so this is the procedure to find out the dot product and cross product. Now, do you have any question regarding this dot product, cross product, and component of vector?
No, sir.
Okay.
No, sir. No.
Okay, now you have to practice some problems which is given as a practice sheet. Basically, same. The file name was some suggested point in problems. Okay.
Sir,
Okay, so I'm, yeah.